This next section, despite taking an entire page, should go on through pretty quickly. So problems 31 through 36 say to list all number sets to which each number belongs: natural, whole number, integer, rational, or irrational. So looking at 31, remember that we said in class that an irrational number for our purposes this year will be any number that has a ... after it or a pi symbol next to it. That doesn't qualify for 31, so we know that it has to at least be rational. And since that is our broadest category, next we have to ask ourselves, does it qualify as an integer? Is it a positive or negative whole number? And since it's a fraction, it is definitely not a whole number. It doesn't qualify for that. So, rational number is the only category to which will be an accurate characteristic of negative 4 over 5. Number 32. Again, it does not have a ... after the number, so it's not irrational. And it doesn't have a pi after it, so it's not irrational. So it has to be at least rational. And is it a positive or negative whole number? No, it's not, so it cannot be an integer. Number 33. Does it have a ... after it? No, it does not. Does it have pi after it? No, it does not, so it cannot be irrational. It has to be at least rational. Again, is it a positive or negative whole number? No, it is not, so it cannot be an integer. Number 5, no ... no pi, so it cannot be irrational, so it's got to be at least be rational. Is it a positive or negative whole number? Yes, it is this time, so it's at least an integer. And we just classified it as a whole number. Since it's positive, it counts as a whole number. And is it a natural number? Is it a counting number that's 1 through infinity? Yes, it is. So that would meet all of our criteria. It is rational, it is an integer, it is a whole number, and it is a natural counting number. Number 35 has 8 pi. And I see right away that this has pi, so once I notice the pi, I know the answer is going to be IRR because that represents irrational. And pi is a non-terminating, non-repeating decimal that goes on and on and on and on forever, so that also qualifies it for being irrational. The term 0. Term 0 does not have a ... after it. It does not have a pi next to it, so it cannot be irrational. It is in fact rational. It is a positive or negative whole number, so it is an integer, and it is a whole number. It's not generally considered one of the counting numbers because counting numbers start at 1 and go through infinity, so it is not going to be a natural number. Problem 37 says to create an expression that is represented by the model. And what I like to do is actually write on the little lines above it. So starting from the dot, it goes 1, 2 forward. I'll call that +2. And then starting from this point, it goes 1, 2, 3, 4, 5 down. So I will call that -5. And when you write an expression, you don't need a positive sign at the beginning of the expression. So I will say 2 plus -5. And that concluded on -3. 2 plus -5 is in fact -3. Create an expression for the following. Again, I'll start at 0, 1, 2, 3, so -3. 1, 2, 3, -3. And so I can call this -3 plus -3 equals, well, 3 and 3 is 6, and they both have the same sign that is negative, so I will keep the sign. -6 is what I got through my arithmetic, and in fact the line does come down to -6. 39, create an expression that is represented by the model below. Well, again, 1, 2, 3, 4, and 1, 2, 3. And I don't need a positive sign at the beginning of the expression because it's understood that the term is positive. So 4 plus 3 equals 7. And in fact, there's 6, there's 7, so that is an accurate expression.